Good afternoon, ma'am.
That's yesterday. What we have discussed yesterday.
Ma'am, last we have discussed wrapping crypto system.
Rabin crypto
Quadratic
system.
congruence.
Right. Quadratic congruence
Okay.
and quadratic residue and non-residue, right?
Yes, ma'am.
Okay.
Yes, ma'am.
So now we need to start with, also I have discussed with you people that we need to understand the Chinese remainder theorem, right? To understand the Rabin crypto system, first of all, we should have the knowledge of Chinese remainder theorem. So I will show you the theorem. We will solve one example also, and then we will discuss about the Rabin crypto system algorithm. Okay. Let me just share my screen. Okay. Is it visible?
Yes, ma'am, visible.
Okay. So I have returned the statement already for the Chinese remainder theorem. Short form is CRT. So it is used to solve a set of different congruent equations with one variable. Okay, now you can focus on these equations. It is said that it is used to solve the different congruent equations. So these are the different congruent equations. Okay, x congruent a1 mod m1, x congruent a2 mod m2, and x congruent an mod mn. Okay, now the next statement is the next is with one variable. With one variable, you can see on the left hand side we are having x. Okay, so that is one variable, but different moduli. Okay, now you can see over here mode m1, mode m2, mode mn. So these m1, m2, mn are known as moduli, which are relatively prime as shown below. Now these m1, m2, mn should be relatively prime. Now we know the meaning of, now you can just observe the statement again and you can see that yes, we know each and everything now. See, different congruent equation. We know about the congruent equations. Yes. Then we know about moduli. Yes. What do you mean by moduli? This m1, m2, m3. Okay. And relatively prime. So yes, we know how to check the whether the two numbers are relatively prime or not. Okay. So now it will be easy for us to understand this equation, to solve this equation. Okay. So yes, x is the different, one variable, but now we should have the different unique, we can say unique solution. But unique solution you will get if and only if your m1, m2 and mn, let's say I'm having three, okay, m1, m2, m3, three equations I'm having. So each of this, that is m1, m2, m3 should be relatively prime. So if I find the GCD of M1, M2 and M3, it must be 1. Then and then you will have the unique solution. So that is the second statement for the Chinese remainder theorem, that these above equations have a unique solution if and only if your moduli are the relatively prime. So that's what I have written over here. Moduli are relatively prime. That is M1, M2, M3, GCD should be 1. Okay. In order to find the value of x, you can write like this. This is your final equation. X equal to A1, M1 into M1 inverse. Okay. So what is A1? Here it is A1, A1, A2, AN, right? This I will let you know how to find M1. Once you find M1, you can find the M1 inverse also. Okay. So these I will show you while discussing the example, but this is the equation A1 M1 M1 inverse plus A2 M2 M2 inverse plus up to whatever the equations are. Okay, the number of equations. So AN, MN, MN inverse mod M. Now, how to find the value of m now? So the equation is m1 into m2 into mn up to mn. Okay, let's say in the above equation we are having three, m1, m2, m3, three moduli. Okay, so what I will write over here, m1 into m2 into m3. So that is the value of what? M. इतना clear हुआ सबको? We have
Yes.
just, yes, we have just seen the type of equation. Yes, this is the type of equation. We just understand what are all these terms. What is a1, a2, an? They are quotient. m1, m2, mn. These are the moduli. And x is the one variable. I need to find the different solution for this, or you can say unique solution for these three equations. And how can I get the unique equation? If and only if your moduli are relatively prime. So this is the whole idea of the Chinese remainder theorem. So shall we start with the example? If this is clear. Yes?
Yes, ma'am.
Okay. So here I have taken the example where you can see 2 mod 3, x congruent 2 mod 3, x congruent 3 mod 5 and x congruent 2 mod 7. First of all, I need to check the different moduli. Yes, I am having different moduli m1, m2, m3. What I have done is I have just mapped these equations like this. These are the original equation that we have seen, right? So what is a1? 2. What is a2? 3. And what is a3? It is 2. What are the values of m1, m2, m3? So 3, 5 and 7. Okay. Now we will just list down the things, whatever is given and what we need to find. Okay. Finally, I have to find what? The value of x. This is a one variable. X is a one variable for which I should have the different solution. And how can I have a unique solution? If my 3, 5 and 7 are relatively prime. So by seeing only I can say that yes, these are the relatively prime. So I will be having the unique solution for these equations. Agree with this?
Yes, ma'am.
Okay. Only 1 or 2 students are learning, I think. Okay. Let us solve this. You can note down these things, huh? So from the example, we can say A1 is given, that is 2. A2 is also given, that is 3. And A3 is given, that is 2. Right? Okay. M1 is also given, that is 3. M2 is given, that is 5. M3 is also given, that is 7. Please pay attention because at the time of solving the Rabin crypto system example, I'm not going to show you this again. Okay, at that time I'll be directly writing this. I will be writing the answer directly. Okay, so this is a given. And this is what you need to find is to find. Okay. Now what I need to find is, see the equation again. M1, M1 inverse, M2, M2 inverse. These I need to find. So I need to find capital M1. See, these are the different things. Huh? Small M1, M2, M3 and capital M1, M2, M3 are the different things. M1, M2, M3. M1 inverse, M2 inverse, M3 inverse. These I need to find, right? I also need to find M. Again, we can go through the equation. See, I need to find what? Mod M. Okay, so I should have the value of M. Now finding the value of M is very easy. I just need to multiply my all the modules. Okay, so let us just find it out. Okay. Just keep in mind that the unique solution is possible if GCD of moduli is 1. That is, they are relatively prime. So GCD of, I will be finding what? 3, 5, 7, and it is 1, right? So yes, I will get the unique solution. First of all, let me find M. So M equal to what? Small m1 into small m2 into small m3. That is 3 into 5 into 7. And that is
105.
105. Right? Okay. Now, how to find the capital M1? So capital M1, the equation is M divided by small m1. That is 105 divided by 3. That is
35.
35. Just a second. Just a second. Finding the value of m1. Okay, so this is the equation. What you need to do is capital M upon small m1, and this is how you need to find the value of m2 also and m3 also. So find it out and tell me quickly.
Value of M2 will be 21
Right,
and of M3 will be 15.
right. M upon m2 I will do, and that is 21. And this I will do m upon m3, that is 15. Right?
15.
Yes. So now I'm having m1, m2, m3. So let us go through the equation again. I know a1. Yes. I have found m1 also. Yes. m2 also. m3 also. I have found m also. Now my next task is to find what? m1 inverse. Right? So let us do that. Okay. Now any idea how we are going to find the m1 inverse? You need to remember the concept of multiplicative inverse, okay? So m1 into m1 inverse, the equation is like this, equal to 1 mod m1. M1 is what? Please don't confuse between capital M1 and small m1, okay? M1 is your moduli, which is given 3, right? Here it is 3. So what is the value of m1? 35. I need to find the multiplicative inverse of this. Do we have done this exercise before? Have we done this exercise before? Finding multiplicative inverse, yes or no? Tell me, have we done this kind of examples? Manthan? Roll number 92. Those are not going to answer my question. I'm going to keep your absent today, okay? "92" roll number. Okay, 81. Bhavanshi. Roll number 81. Smith 103.
Yes, ma'am.
Have we done this kind of examples? Multiplicative inverse.
Yes, ma'am. We have done in the class.
Right? We have done this in the class. So you people know this, how to find M1 inverse now? Tell me how we are going to find this. What was the procedure? I need to find M1, the value of M1 in such a way that if I multiply it with 35 and divide it by 3, the remainder must be 1. That was the concept. So here we were putting like 1, then 2, then 3, like that. We need to try it out, right? And one number you will get that if you multiply that number with 35, let us say x into 35, and if you divide it by 3, then you will get the remainder 1. So you will find the value of what? M1 inverse. Getting? Yes or no?
Yes, ma'am. Ma'am, I think M1 inverse will be 2.
Yes, because if I'll put 1, so 35 divided by 3, if you do, you'll not get remainder 1. So I will try with 2. Okay, so 35
70.
You
into
also
2.
want to try with Fermat's theorem. That is also
Yes,
applicable over here.
yes. So yes, we have done, yes, very good. So Fermat theorem you can also use over here, right? So we have done this small theorems, but then you need to apply it out, right? We have done this also. Multiplicative inverse kaise find? This is the simplest way. One more trick also I have told you, right? So that you need to remember, you need to understand when to apply, right? When to apply and where to apply. Okay, so yes, M1 inverse value will be 2 because 70 by 3 if you will do, then you'll get the remainder 2. Okay.
Ma'am, 1, right? Remainder will be 1, I think.
Sorry, remainder will be 1. M1 inverse value is 2. Okay. Yes, this is how you need to find for M2 also. So M2 into M2 inverse equal to 1 mod M2, small m2. So that is what? Value is 5. So you need to find the value of M2 inverse in such a way that if I multiply it with this M2, what is the value of M2? 21, right? So I'm just putting it into the equation. 21 into M2 inverse equal to 1 mod 5. So tell me the value now.
6.
1 से start करना है.
तो 1 मार થઈ જશે.
1
मैम 1 भी हो जाएगा ना, 1 भी हो जाएगा.
Right, 5 fours are for 20 and remainder will be what? 1. So M2 inverse value is 1. Okay, and tell me for M3 inverse. M3 into M3 inverse equal to 1 mod M3. And the value of M3 is what? 15 into M3 inverse equal to 1 mod small m3. What is the value of small m3? 7, right?
मैम आई थिंक ये भी 1 में ही हो जाएगा.
Right. So 7 to the, sorry, the remainder will be 1. Yes, 15 into 1, and if you divide it by 7, you will get what? Remainder.
1 as a remainder.
1 as a remainder, right? So now we are having all the values. M1, capital M1, M2, M3, M1 inverse, and A1, A2, A3, right? So let us take our equation that is this equation. Okay, I will put the values in it. I have m also, right? Capital M also. I'll put the values and then I'll find the different solution for this equation. Okay, so let us do that. X equal to A1 M1 M1 inverse plus A2 M2 M2 inverse plus A3 M3 M3 inverse mod M. Now quickly tell me the values, all the values. What is the value of A?
2.
2 into 35 into 2 plus
3 into 21 into 1.
3 into 21 into 1 plus
2 into 15 into 1.
2 into 15 into 1 mod,
Mod M.
that is 105,
5.
right? Okay, tell me this calculation. Tell me the value of x directly.
233 mod 105.
233 mod 105 and
23.
yes, x will be what? 23. Now we are having these equation x congruent a1 mod m1. Okay, put the value of x over here. We just need to check that yes, if I divide it by, let a1 is what? 2, right? And mod m1 is 3. So if I divide it by 3, x की वैल्यू हम 23 रखते हैं, divide by 3 करते हैं, so remainder 2 आता है.
Yes, ma'am. 3 into
Yes.
7, 21.
So yes, so that is the correct. Okay. Now same for A2 mode M2 and A3 mode M3. Just check it out.
So, ma'am, the steps that we are currently doing are for verification. that
Verification,
whether
yes,
the
yes.
answer is correct or not.
Yes,
Okay.
yes.
We don't need to mention it in exam.
No, no, you don't need to mention.
Okay, ma'am.
We just need to find the value of x in the examination.
Yes, ma'am, it satisfies all three equations.
Right? It satisfies all the three equations. So what we can do, we can state over here is the x is the variable, single variable for which we are getting the different moduli, right? And also we need to check what? That is to find the different congruent equation. We have found the different congruent equation for the one variable, that is x. Okay. Now this theorem you will be not asked in the examination to solve this kind of example. This is a theorem that you need to apply in the other algorithm. Okay, that is one of the step. As we have done, that is how to find the modular exponential. Now that was just a step in RSA algorithm, but then we need to study the whole thing, right? So this theorem, you just need to find the solution in one of the step of Rabin crypto system. So theorem you just need to apply. Okay, उसके examples आएंगे ऐसा जरूरी नहीं है. ये आपको दूसरे algorithm में सिर्फ क्या करना है, use करना है, apply करना है. Getting?
Yes, ma'am. So this will be in the middle process of any algorithm.
Yes, yes. Okay, so I think this is clear to all. No need to do the second example. As I told you that we just need to understand this and we need to apply this whenever required. Okay, clear everyone?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. So let us just see the procedure of Rabin crypto system. Let me just share my screen again. Okay. So as you can see, the equations are given for the plain text and cipher text. Okay, that is for encryption and decryption. Okay, so these are the forms of the equations for Rabin crypto system. I'll show you the flow. Okay, again, as we know that it's a asymmetric crypto system, right? I should have the public key, which I'm going to announce, right? Anyone can encrypt, but then it is going to be decrypted by what? Private key. Okay, that only the receiver will be having. Okay, so the Rabin crypto system can be thought of as an RSA in which the value of E and D are fixed. In case of RSA, what we were doing, we were assuming or we were given the value of E based on which we were finding the value of D. Right, and then these two keys, E and D, were the keys, right? E was the public key and D was the private key. So that we were using in finding the cipher text and plain text. Correct? Yes or no?
Yes, ma'am.
Okay. Now here are the equations for Rabin crypto system. That is to find the cipher text, plain text raised to 2 mod n. C congruent P square mod n, and decryption is P congruent C raised to 1 by 2. Basically it is like this, root C mod n. Okay, I'll show you how to simplify this equation. Okay, so that's why it is written C raised to 1 by 2 mod n. Let us go through the procedure and the flow. Now here the whole scenario is given. Let us assume that Alice wants to send some message to Bob. In this case, Alice is a sender and Bob is a receiver. Okay. So how Alice is going to encrypt the plain text? Using the public key. Agree with this?
Yes, ma'am.
Okay. So very first step is key generation. Okay. If Alice wants to send a message to Bob after encryption, she must have the public key of Bob, right? So the key generation says that very first step is select the value of P and Q. Once you have select the value of P and Q, do this, n equal to P into Q. Okay. Again here your P and Q will be what? Large prime numbers. Okay. Then next step is n, to find the value of n. Now these n, Bob is going to announce these n as his public key. Bob will say that yes, this n is my public key. He is not going to tell that yes, this is the factorization. Okay, let us say that P equal to 11 and Q equal to 7. So he directly says that n equal to 77. That is my public key. Is not going to tell that yes, P and Q are this and that, right? So N is the public key which is announced by Bob. Now what Alice will do? She is going to use this N. You can see the equation. Here is the public key which has been received. Okay. Now plain text C equal to p square mod n, प्लेन टेक्स्ट जो भी है, सपोज उसे सेंड करना है 5, 5 is the plain text. So 5 square mod n. What is the value of n? It is 77. So this is how she is going to encrypt it. Okay. But then we need to fulfill some of the condition that I will let you know while writing the whole steps of the algorithm. This is just a flow. Okay. Okay. So plain text has been now converted into ciphertext. Okay. Ciphertext which has been received, this C has been received by Bob. Now what Bob will do? Bob is having the pair of P and Q. Okay. Now this pair of P and Q is a private key. In RS algorithm, what we were doing? We were assuming one more value E. Okay. That must fulfill some of the condition. जैसे relatively prime है या फिर वो सब आपको check करना है, right? Just go through the procedure of RSA again. If you don't remember, okay? We were choosing the value of E and then we were putting it into the equation, right? And then we were finding the value of D. Now D was working as a private key. So you'll be having a single value. Here you are having the pair. Okay. So P and Q, which we have selected as the prime numbers, / prime numbers, these are going to work as what? A private key. Okay. So this private key going to be used for the decryption and you will get the plain text. Now you can see in the middle that there is some, let's say E is one of the user, or we can say an attacker wants to stall the or wants to read the plain text. Okay, wants to retrieve the plain text. What she has to do is she has to do this in order to get the value of plain text, root C mod n. Now here Rabin crypto system is a deterministic. Just a second. Meaning of deterministic algorithm over here is that you will be finding 4 different plain text value for single input. And the reason is this equation. We'll go into the detail, but for now, it has been written that why it is infeasible for Eve to assume the plain text. The reason is the Rabin crypto system is deterministic and the meaning of that is you will find decryption में हम क्या करते हैं? Just reverse process of encryption, right? Equation is such a way that you will get the 4 different value of the plain text. Now it is up to Bob that what to select as a plain text. It depends on the situation. Now Bob has to do some extra task in order to get the original plain text. Okay, so one of the disadvantage you can say of Rabin crypto system is that you have to do the extra complexity. You have to do some extra work in order to get the plain text, right? In the previous case, there was a single key that was D in RSA and we were just putting the values and we were able to get the plain text again, right? But here you can see that this P and Q tuple are the private key. I'm having a pair, okay? And what is the equation of the decryption? That is root C mod n. We will simplify this equation and I will show you that how we are getting this 4 different plain text value. So this is one of the disadvantage, but then the advantage is what? Factorization. Factorization of n. Okay, the attacker has to do the factorization of n in order to assume the key. Here the key are what? P and Q. Okay, so he or she has to assume the value of I have to do the factorization of n in such a way that he or she gets the correct P and Q. Okay, and then also these P and Q should be applied for the 4 different plain text, because you'll be getting 4 different plain text whenever you are using this Rabin crypto system. थोड़ा बहुत clear हो रहा है flow?
Yes, ma'am.
Yes, ma'am.
Okay. So now we will be writing the algorithm, and then we are going to discuss about the example. So let me just choose OneNote again. Yes, here it is. Okay. So you can note down this while I'm writing Rabin crypto system. Okay. So the very first step is key generation. Just a second. Hello. हाँ बोलो अल्पेश भाई. Okay, sorry for the interrupt. Okay, so the first step is key generation. Okay, so as I told you, in this, what we need to assume is assume 2 prime numbers P and Q. Okay, now this prime number should be selected in such a way that it should be congruent to 4k plus 3. That is, जब भी मैं इसका मॉड्यूलो ऑपरेशन परफॉर्म करूंगी, ओके, तब रिमाइंडर क्या होना चाहिए? 3 होना चाहिए. Okay, we will select the P and Q, and I will let you know that yes, this is satisfying this 4k plus 3 condition. So the very first restriction is you need to assume P and Q, but in such a way that it should be congruent to 3 mod 4, or you can say 4k plus 3. Okay. Now the next thing is the value of P and Q should not be equal. So P and Q both should be prime. It must be prime. They should be prime in such a way that they fulfill this condition, that is 4k plus 3 form, or you can say congruent to 3 mod 4. Okay, and another condition is the P and Q value should not be equal. This is the first step in key generation. The second step is N equal to P into Q. Next step is to announce the or to select the public key, that is nothing but the value of n. Next thing is to select the private key, that is private key is what, as I told you, P and Q. So now you can see that if we are having the two keys and if I'm having the equation, that is plain text P equal to, what was it, root C mod n, ये equation था, right? So whenever I'm going to calculate this, I will be having the 4 different solutions. Here you need to use what, P and Q as a private key. These are just the steps. We have to use these in the example. We need to understand these using the example. Okay. The next step is I have the 2 keys now. What I will do in next step, I will encrypt my text. So for encryption, we are having C equal to P square mod n. Okay. Now decryption. So as I told you, that decryption will be having the 4 different values, and here it is how it is possible. Decryption. So MP, I'm writing P because this decryption I'm doing with P. The another decryption I'll be doing with what? Q. Okay. So MP equal to root C mod P. And the another possibility is MQ because we are having 2 private keys. Here it is C mod Q. Agree with this? If I'm performing decryption, if my private key is P and Q, if it was D simply, then only one possible solution will be there. But as I told you that in Rabin crypto system, it is deterministic. That means we are having P and Q both as a key, and the receiver has to decide, or the receiver has to decrypt it with both of the keys. Okay. So now the question is arising over here that yes, we do have only 2 solutions. I mean 2 equations. So MP and MQ, these are your decrypted message. Okay. But then you need to solve this root also. Okay. So root C को हमें simplify करना है. So once you simplify it, you will be getting plus or minus C raised to P plus 1 divided by 4 mod P. Okay, P and Q you already have chosen. That you need to keep private. Plus or minus C raised to Q plus 1 divided by 4 mod P. And this is how you can see now we are having total how many decryption possible, how many plain text possible after decryption? 4. Plus minus this with P and plus or minus this with, sorry, here it will be Q. Getting? And to solve these, to solve this, we are going to use what? Chinese remainder theorem. Okay, if you know the whole algorithm, if you have written all the steps, these are the simple steps. See, assuming P and Q with fulfilling condition, calculating and okay, that has been done. Encryption, okay, that is also been done. But then for the decryption, you must know the another algorithm, that is CRT. If you are not knowing this, then you are not going to, you will not be able to solve the example. So now you can understand the importance of these concepts. Clear, everyone?
Clear, ma'am.
Okay,
Yes,
so these are just the steps. We are going to do the example in the next lecture. I will give you some more examples in exercise also. Okay, so it will be easy for you.
अब कल करेंगे कल कितने बजे फ्री हो आप? एंट्री तो मैं कर लूंगी देख देख के।
Let me just
तो अगर
take your
कोई चेंजेस
attendance.
वगैरह आया
मेरा सब तो नहीं आएगा
Okay, I have taken your attendance. You may leave the meeting. Thank you for joining the lecture.
and this is 6 is here
मैं मॉर्निंग में कर दूंगी अगर जो कोई चेंज आया तो मैं 11:10 को